virtualization, configure and verify data paths, virtualization technologies such as virtual routing and forwarding. So this virtual routing and forwarding feature in Cisco will let you have virtual routers that will live within your physical router in such a way that each virtual router will have its own routing table, and these routing tables that belong to each virtual router are unaware of the existence of other routing tables. With this feature, you can accomplish having duplicate addressing as long as each addressing keeps within the realm of its VRF routing table. This works great for carriers that want to provide connectivity to several customers where the customers are using the same IP addressing scheme. The routing table that does not belong to any VRF is known as the global routing table of GRT. Think of it as the normal, regular, plain vanilla routing table that you have been working with historically. That is your global routing table. When you start configuring a router, all the interfaces of interfaces, virtual interfaces, tunnels, loopbacks, all belong to the global routing table. So you can start moving these interfaces and subinterfaces to your VRFs as you want. You can also bind your static or dynamic routing to a VRF. Be aware that this VRF topic is huge. You can go as far as to configure multi-protocol BGP with MPLS, with VRFs within your network, and you will end up having a very complex VRF network. Or you can choose to use the VRF Lite feature. With VRF Lite, the VRFs that you create in one router are unaware of the VRFs that you create in other routers, so they have a local scope. In order to configure a VRF, you will have to enter a route distinguisher. So with VRF Lite, these route distinguisher numbers have a local scope. They are unaware of the route distinguishers that you are using in other routers. So VRF Lite is quite cool in that matter. In order to create a VRF, use the command VRF definition, and in there you will have to establish the route distinguisher, which is a number, a pair of numbers. Remember that you can choose any pair of numbers that you want, as long as they don't repeat among VRFs. Remember that these route distinguishers are not shared with other routers when using VRF Lite. And then you will have to assign interfaces to your VRF with the command VRF forwarding and VRF name. And in order to troubleshoot, you will use the command show IP VRF or show IP route VRF. Some real life scenario that you will come across is communicating a device that is connected to your global routing table to another device that is that lives within VRF. So in order for doing this, you will have to do something that is known as route leaking between the VRF and the global routing table. You can accomplish this using several features. For instance, you can use the BGP VRF Lite feature, in which you will inject your global routing prefixes into BGP, so BGP can help you import those routes into the VRF domain. In order to use this, you will need to have multi-protocol BGP in your device. The other ways to do this is by using policy-based routing, in which the difference here with the normal policy-based routing is using the statement set global within your roadmap. In order to use this feature, you must be aware that some low-end multi-layer switches will not support policy-based routing in order to do route leaking. You can also use the VRF Receive feature. You will enter these commands into your global interfaces that you want to make them participate into a VRF. But remember that this feature is only available on some high-end devices, particularly in those service provider operating system images. We'll review this in the lab.